Hello and welcome to Help Your Math. In this video, we are going to talk about the definitions of three different types of variation. What is variation, you may be asking? Great question. Variation is the way in which two or more quantities can relate to each other. We're going to talk about three main types in these upcoming videos: direct variation, indirect variation, and joint variation. First up, we have direct variation. We can say that y varies directly with x if we can write y equals k times x. You might notice that this is a linear equation, and this particular linear equation would have a slope. So remember, the slope is being multiplied to our x, so it's a slope of k, and a y-intercept of, this is written in slope-intercept form. I don't see anything. We would represent that nothing being added with a 0. So this would be a y-intercept of 0. Indirect variation, we would say that k is the constant of variation. So linear equation, we call it the slope. Direct variation, we call it the constant of variation. We see direct variation in so many places in the real world, including economics. And the first example that comes to my mind is an hourly salary, right? So if you work 10 hours and your pay scale is $22 an hour, you're getting 22 times 10. And that's going to change. The 22 would be our constant of variation. And what's going to change is the number of hours that, in this case, Jed works, and then how much money you're earning based on how many hours you've worked. We can also see direct variation in physics with a lot of examples, some of which would include speed and distance. In cooking, so if you have a recipe but you want to double it or triple it, that would be a result, the new amounts, the new ingredient amounts would be a result of direct variation. And now I pose the challenge to you. Can you think of any other examples of direct variation? Okay, so now that you've thought about direct variation, we're going to switch entirely and go with indirect variation. We say that y varies indirectly with x if we can say that y equals k over x, and we just say that k can't equal 0 because then there would be no relationship. Unlike direct variation, the variables in indirect variation do not have a linear relationship. These are more like a reciprocal relationship, although it's not entirely reciprocal because we do have k, but it is more similar to that. Here we call k the constant of proportionality. Indirect variation also has many, many real-world applications, such as work. So if you have one project, the amount of work per person will decrease based on how many people are helping with the project. Economics, buying in bulk, you might be able to have lower prices as a result of buying more of a product. In physics, again, we're going to see a lot of physics here in this section. Ohm's law, in which there is a relationship between current and resistance, and many, many others. What else can you come up with that relates indirectly? Last up, we have joint variation. Joint variation, we introduce a new variable z. We may see a joint variation if we see z equals k times x times y, where k does not equal 0 again. And that would be our joint variation. So we say that z is jointly proportional to x and y. One really, really common example of joint variation is the simple interest formula, which is that interest equals the principal times rate times time. So generally the principal is going to be our k value, the one that doesn't change, right? That you put in a certain amount of money and that's all there is, right? You invest $10,000, that's going to be $10,000 throughout the entire problem. The p will never change. Maybe you invest $20,000, right? So we hold that constant. And then what might change is the rate and the time, and then those would directly or jointly affect how much interest you earn. Other common examples or places where we might see joint variation is in geometry, the area of a rectangle, that's A equals L times W, but we could throw another variable K in there, whatever constant we have. We see it in physics again, Newton's second law of motion, which later there's an example of that, and many others. Can you think of an application in which we use joint variation? These have been the definitions of direct, indirect, and joint variation. Thank you for stopping by.